Hey, we're working literal equations. We're solving for, what are we going to solve for? We're going to solve for y in this problem. Let's say what in the world? That's, sure I got the, no. X plus 2y minus 7 is equal to 0, and we want to solve for, let's solve for y. So this whole thing for solving for a variable is pretty important. In this particular case, remember we said literal equations were equations constructed of a bunch of constants. In other words, we're given some values for these equations to plug them in. But we're just looking at this general for right now. We're solving for y. What do we want to do? Well, let's subtract x from both sides and add 7 to both sides. How's that? Or you could think about it like this. Just take an x over. Okay, there's a plus. It's positive. We take it over to the right, it becomes negative, and then we're going to take this 7 over. And because it's a minus 7, it becomes positive 7. So this is just a whole lot faster doing it this way. So we have a positive, brought the 7 over, it becomes positive 7. And now we have minus x. So you could subtract x from both sides and add 7 to both sides, we get the same thing. Okay, what do? We have y is equal to 7 minus x. It's a coefficient, just take it diagonally down. Right, this is the fast way of doing that. I mean, you're multiplying both sides by half. But I have beaten that horse, I don't know how many times, in the head. If you've been following me with all these problems ever since linear equations, you should be catching on by now. Let's say we have s is equal to 2x squared plus 4xy, and we want to solve for y. Let's say I want to solve for y in this problem. There it is. Okay, we've got to isolate that y. What are we going to do? Let's take the 2x squared and bring it over. So we have s minus 2x squared. We'll go ahead and rewrite. And because this is multiplied by 4x is multiplied by y, we can just bring it diagonally down. Bring it diagonally down. Right, this is the shortcut way of doing things. Okay, in other words, you're multiplying both sides by 1 over 4x to both sides. Okay, let's look at another one here. A is equal to a half times h, and b sub 1, these are subscripts, b sub 2. Okay, they're just, I should say, they're constants, variables, and they're supposed to be constants. We're talking about literal equations here. Alright, I want to solve for b sub 1. Solve for b sub 1. So I want to multiply both sides by 2, or this half right here, right? Multiply both sides by 2. You're going to get 2a is equal to h times b sub 1 plus b sub 2. Okay. Now multiply both sides by 1 over h, and that we end up moving the h diagonally down. And remember, we're solving for b of 1 here, so subtract b2 from both sides, and we're left with 2a over h minus b sub 2. And that gives us our b sub 1. Okay, pretty simple. Catching all that? Alright, I'm clearing the screen. I hope you got it. It's time to move on. Trying to knock some stuff out here. Let's say we have b is equal to p plus prt. B is equal to p plus prt. And we want to solve for r. Want to solve for r. So we're going to subtract p from both sides. So we're left with b minus p is equal to prt. We're solving for r, so we're going to multiply both sides by 1 over p over t, and that ends up, right, because they're multiplied, just take this p and this t down diagonally, and that's equal to r. We were trying to solve for r in that problem. We'll get back to that problem at some point in time. Let's see, what else? Can I do one more? Let's go ahead and get this one out of the way. Let's do this last one here. So I just had one left. This is one that you're going to be working over and over again. Not in this course, but in the next algebra course. Yes, you'll be working this over and over. Alright, so we want to solve for x sub 1. I want to solve for x sub 1. What do we do? Well, multiply both sides by 1 over m. And so we're left with y minus y sub 1 over m. Okay, over m. What do we do now? Well, you notice this is minus x of 1, and we're trying to solve for x of 1. What I would do is take this over to the right and take what you see here over here to the left. There were several ways you can do this problem. Quite a few ways, but this is what we're going to do. So we have x, by taking this over, because the sign out in front of is positive, when we take it over it becomes negative. Is equal to, and because this is a negative sign here, or minus, we take this x of 1 over to the right, it becomes positive. That's what we were wanting to do. In other words, we were just adding x of 1 to both sides. Okay, adding x of 1 to both sides. So there you go. Now, yes, this guy here, this particular equation here, that m could represent the slope of a line, and those y's and x's represent coordinates. Anyway, we'll talk about that later on in the story. Okay, so that pretty much ends this section on literal equations. Hopefully you got it. We're moving on to bigger and better things. We got some application problems coming up, and we're going to be applying some of this stuff. Alright, see you in the next section.